Good day to you. This is the lesson for Algebra 2 for April 2nd, 2020. So we are nearing the end of this unit, so I'm thinking that in the next couple days we'll maybe review a little bit, and then we'll have a small quiz or small test assessment kind of thing. I'll kind of lay out the details about that. I think it's going to be, the test and quiz will be open notes, and you can watch the videos and stuff like that too if you want to. The only thing that I'll ask you is that you please just don't ask anybody else for help, that you really just do the work all on your own. And we'll talk about maybe allowing for retakes or anything like that, possibility too. So yeah, please just do the work on your own. Don't look up any answers. Do the work yourself. Anyway, on to what we're doing today. Today we're just going to continue on with what we were kind of looking at yesterday a little bit. All right. Technically, the section in the book that calls this is the book calls this complex solutions to polynomial equations. Okay, and so that's what we're going to be looking at today. All right, the big principle here that we want to kind of I want you guys to really connect and understand is that the degree of the polynomial determines how many intercepts, or not intercepts, let me say solutions the polynomial has. Okay, these solutions can be real or imaginary. Okay, so understand that too. They don't have to, they could have I or they could not have I. Okay, so that's a fundamental thing. So let's take a look at how we can kind of use this idea, or how this idea kind of shows up. So for example here, let's start with something like what do I want to start with here? All right, let's start with something like this. X to the third plus 8x squared plus 21x plus 18. Okay, so we want to find the zeros. Okay, again, finding the zeros, that would be, again, the solutions to this equation right here, okay? And the number of solutions that we're going to have, what we'd expect is, well, what's the degree of this polynomial? All right, so if you look here, the degree of the polynomial is 3, so we'd expect to have 3 solutions, okay? So let's see what happens here. Well, as I look at this, I see that we could try and factor this. We could group here, for example, and then group here, for example. If I factor out an x squared from that first group, and from this second group, I could factor out a 3. But you can see here that we don't have the same leftovers, and so factoring by grouping will not work. Okay, so we're going to have to rely back on our P and Q stuff. Okay, so so again, there's our P, there's our Q, it's 1, and so we will say, let's see, the factors of P, so that's going to be plus or minus 1, 2, 3, 6, 9, and 18, and the factors of Q are just plus or minus 1, and so then our possible zeros are 1 over 1, 2 over 1, 3 over 1, 6 over 1, 9 over 1, and 18 over 1. So let's see. So that's all going to just be the plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. Okay, and so let's see here. Let's try one of these. So we'll just go to synthetic division here. I'll try 1. Okay, 1, 8, 21, and 18. Drop the 1 down, and so we get 1 times 1 is 1, 9, 9 and 1 is 9, so that's 30. 30 and 1 makes 30, and that's going to make 48, so clearly that one doesn't work. We can keep just guessing and checking here. I'm going to try 2. 1, 8, 21, and 18. Okay, drop the 1 down. 1 times 2 is 2, that's 10. 10 times 2 is 20, that's 41. That's going to be too big, so yeah, this one's not going to work either. Let's try negative 2. All right, 1, 8, 21, and 18. So we get 1 there. 1 times negative 2 is negative 2. That makes 6. 6 negative 2 is negative 12. Negative 12 and 21 makes negative 9. And that makes, not negative 9, sorry, positive 9 when I add those together. And then that makes 18, negative 18, which makes 0. And aha, we found one that works. So negative 2 is one of our zeros. Okay, and remember our leftover here, since we started with a cubic up here, right, that is a cubic, then our result will be x squared plus 6x plus 9. It's quadratic, right? We can try and factor that. We'll set it equal to 0. We need two numbers that multiply to make 9, but add to make 6. So that's going to be 3 and 3. Okay, and so we can set each one of those equal to 0. And we get x equals negative 3 and x equals negative 3. So you can see we have 1, 2, 3 zeros here. Now, you'll notice that the negative 3 occurs twice. Okay, so you might be like, Mr. Wid, that's only 2 zeros, and that's true. But we count repeats as, you know, as extra zeros. Okay, so what you could say here is that you have zeros at negative 2 and negative 3. Okay, now negative 2 has a multiplicity of 1 because it only occurs once. And then we say negative 3, though, has a multiplicity of 2 because it occurs twice. Okay, and that would be our final answer there. Okay, let's try another one. Okay, so let's take a look at this one. This one we've got p of x equals x cubed plus 7x squared. So again, we'll find the zeros. And let's go ahead and label the multiplicities too. Okay, so now for this one, we'll again take it equal to 0. Okay, and in this case, I can see that we can factor, right? There's a GCF here we can factor out. We'll take out an x squared, leaving behind an x and a plus 7, which is equal to 0. Okay, then we'll set each one of these factors here equal to 0, and we can solve. So if I square root both sides, I get x equals 0, and I'll subtract the 7 over here, and we get x equals negative 7. Okay, so negative 7 has a multiplicity of what? Well, it only occurred once, right? It had a little exponent here, 1, right? You can imagine. So it only has multiplicity of 1. Okay, what about this 0, though? What's its multiplicity? Remember where it came from. It came from this x squared right here. And that x squared has a power of 2, which means then this has a multiplicity of what? And you should say 2 there. Okay, because that 0 occurs twice. So again, you can see we have 2 zeros, 1 0. So 2 plus 1 makes 3, which is the degree of our original polynomial there. Okay? All right, very good. Let's try another one. Okay, so let's try this one here. Okay, so this will be our last example here. So, again, why don't you pause this here and try it on your own to see what you can come up with. Okay, we want to find the zeros. Okay, so hopefully you pause this. So to find the zeros, right, we'll set it equal 0. And of course, at any point, if you want to pause the video and then start from there, right? If you get stuck and you just need like a little help, you know, pause the video, or unpause the video, I should say, you know, watch my example as I go a little bit further, and then pause it again to continue on, right? So anyway, from here we can see, if I want to, again, find the zeros, I can see that I have a GCF here, right? This is x, this is x, this is x, this has an x as well. So I'll take out an x, which leaves me with x cubed plus 3x squared minus 4x minus 12. Okay, now if I look here, I have 1, 2, 3, 4 terms. And that means I can maybe try grouping here. So again, let's try grouping. Let's imagine I put parentheses around this, parentheses around this. Let's see if we can factor by grouping. So from this group, what can I take out? And it's an x squared, right? So x squared, and I'll have an x and a plus 3. And then from this group, what can I take out? What's the biggest thing we can take out? And it's a negative 4. Okay, and lo and behold, we do have the same leftovers, so aha, we can actually, factor by grouping, I should say. Oops, I forgot to write the zeros there. So we'll have x plus 3 when I take that out, and then what's left over from the x plus 3? Well, we'll have the x squared and the minus 4 left over. And that's all equal to 0. Okay, I'm going to do more work over here now. So now we'll take each one of these 3 things that are being multiplied together here, and we'll set them equal to 0. So we get x equals 0, we'll get x plus 3 equals 0, and we'll get x squared minus 4 equals 0. Okay, and so then x equal to 0, ta-da, right? Minus 3, so you get x equals negative 3 there, okay, ta-da. And then we will add 4 to both sides here, so you get x squared equals 4, and then we square root both sides. X is equal to, now, not just 2, right? Since we're square rooting in an equation setting, we need to put a plus or minus 2 there. So how many zeros do we see? 1, 2, 3, 4, and look at our degree. Okay, our degree was 4. Okay. Sorry, I do have one more I want to show you. I forgot. I need to show you one more here that I need to do. All right, so we'll do that real quick. I did say that this was called complex solutions to polynomial equations, right? So let's see what I mean by that. Okay, let's see if I can find one that I... All right, well, let's just do this one. Okay, again, find the zeros of x cubed minus 64. So we'll set it equal to 0. Okay, so again, we want to factor this thing. Okay, we want to factor it. If you remember your difference of cubes formula, the difference of cubes formula is a minus b, or sorry, I should do it this way. We have a cubed minus b cubed equals a minus b times a squared plus ab plus b squared, like that. Okay, so in this case, right, our a is like the x, and the b is like 64, but it's not 64. It's really 4 cubed, like that. So x is our a, 4 is our b there. So what does that factor to be? Well, you can factor to be then x minus 4, which is our a minus b, times our a squared. So a squared will be x squared, and then plus 4x, because again it's ab, and then b squared will be 16, right? Because 4 squared is 16. Whoops, b squared. Okay, like that. That's one way you can factor it. An alternative way to factor this is to use the guess and check with your synthetic division and stuff like that. So you can do the factors of p, factors of q stuff. Okay, remember p would be the negative 64 there, q would be equal to the 1. So you'd have plus or minus 1, 2, 4, 8, 16, 32, and then plus or minus 64, and then q would be plus or minus 1. Okay, so you'd have to guess and check those. You can also look at your graphing calculator. If you just graph this thing, if you graph your original polynomial and just see where it equals 0, that can also help you figure out what your zeros are too. Okay, anyway, so again, this is still equal to 0, so we can set x minus 4 now equal to 0, so we get x equals 4. There's one of our zeros, right? But we also get this equal to 0. Okay, now we know, since the degree is 3, that we need to have 3 zeros, but right now we only have 1. If you look at this quadratic here, you can see we can't factor it. There's no two numbers that multiply to 16 and add to make 4. So what do? Well, what we have to do is use the quadratic formula. Again, you will have this available to you. You can feel free to look it up or whatever. It's going to be, open notes, so you can, use this video if you need to help you out. But it's going to be x equals -4 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay? And then we simplify here. So we get -4 plus or minus the square root of 16 minus, let's see here, 4 times 16 is 64, be minus 64 over 2. So it's -4 plus or minus the square root of, let's see here, 16 minus 64 is 48, negative 48 over 2. Now we have a negative in a square root. Remember what that means? We're going to use what letter for a square root of a negative? We're going to use I. So we'll have -4 plus or minus, so we'll say this is the square root of -1 times the square root of 48. And so it's just going to be I root 48 over 2. And then you want to try and simplify this square root as much as you can here. So let's see here. 48 is divisible by 16. 48 is root 16 times root 3, and root 16 becomes just a 4. So we'll have -4 plus or minus I 4 root 3 all over 2. And we can divide this and this by 2, and so we end up with -2 plus or minus 2I root 3. And there are our other two solutions, right? The plus version and the minus version are our two solutions. Okay? So keep that in mind. All right. There are other situations you could potentially run into here. I'm going to really quick because I know I'm going over my time. But just as a real quick example here to show you, like, it doesn't have to be that hard. You might run into a problem where it works out really nicely. So for example, well, I don't know, let's just say you have like 3x to the third minus, 27x. Okay, equals 0, right? And we want to solve that. Well, again, we can factor out a GCF here. We'll take out a 3x, and we'll left with x squared minus 9 equals 0. And, oops, actually, I want to make this plus. There we go, make it plus. And then we can set 3x equal to 0 and x squared plus 9 equal to 0 there. Okay, divide both sides by 3, x is 0, right? And subtract 9 on both sides here, and get x squared equals -9. Square root that. Well, now we're square rooting a negative right there, right? So we have to make sure we make that simplified using I. Remember, the square root of 9 is just 3, so it's going to be 3i. But since we're in an equation, we should plus or minus 3i. And so there are our solutions right there. Okay, and there are 3 solutions. So anyway, stop there. Give you guys a homework assignment on this. All right. So remember, long story short, factor if you can, like we did right here. Okay, use synthetic division if you can't get it to factor, okay, until you get down to a quadratic. And if you can't factor the quadratic, you need to use quadratic formula, okay, to get your other zeros. All right, I'll just give you like 2, maybe 3 problems for homework tonight.